Hello, I'd like to talk about a new sort of displacer for the Stirling engine, a very fundamental part of the Stirling engine. It hasn't really changed since 1816. Usually it's a metal cylinder and a metal displacer, but the whole point of the displacer is that it is not a piston. Air can slide round the side of the white displacer and it is touching the white displacer and the glass cylinder. Now if my hand were in fact flames, then it would be very hot. The cylinder would be hot, and as I raise the displacer, air comes round it and is heated in that narrow gap between the displacer and the cylinder, and when the air is heated it makes pressure, and that pressure can push the piston. So I raise it, air is heated and the piston is pushed. Now not a lot has happened for 200 years, except perhaps with the low temperature differential Stirling engines. So here are two Stirling engines. The blue pieces are the displacers. So when the displacer is up, the air is down the bottom and picking up warmth. And when the displacer is down, the air is up the top with touching cool air, and the pressure changes, and that drives the pistons. So Mike Dan is proposing a new idea with the displacer. He's suggesting that we have a disc, but the disc is in fact a spring, a volute spring, a spiral. Now if the flames were underneath, making the bottom plate hot, then when the displacer spring is raised, air goes into those slots underneath and is heated. And then when the spring goes back in those slots, the air is displaced and forced upwards into perhaps another set of grooves. So we have a sandwich, two sets of grooves and an oscillating spiral spring in between that drives the air from into the hot space or into the cold space. That change of temperature will make pressure and can drive the engine. Now the interesting part for me is that we can change the density of the Stirling engine, because here we've got 3 turns. If we had 30 turns, making the grooves perhaps narrower, but we could get more heat transferred into the gas, so the power density of the Stirling engine could be increased. An engine has been made, and let's have a look at the video of it. Now let's take a look inside the engine. Here's a cutaway, animated. Oh, you can see that there are 2 displacers in there. There's a red one that is going up and into the red hot dome, and there's a blue one which is going down into the blue dish. Now, please don't worry about the slight hesitation. That's a software gremlin. It should all be continuous. Now, when you take the top off the engine, this is what you see. That is a displacer, and it is resonant. It has its own natural frequency, and it springs from one side to the other side and back again. This is quite a comparison with the normal old-fashioned displacer, because you've got to put energy into the old displacer to make it move. I had to push down the white displacer to get it down. I had to stop it Then I had to push up to get it up again, and then I had to put braking effort in to stop it again. And all that takes efficiency out of the engine. So this is an advance in that we now have a device that draws less energy from the engine and raises the efficiency of the whole device. So there we have it, a radical new development for the Stirling engine, the first in 200 years. As such, development needs funding. And if you would like to become a business partner with Stirling Global, please follow the link below. Thank you for watching.